So looking at the notes, I realized I really probably could have just made everything into one video because we only have a couple of examples left. But oh well, that's poor planning on my part. Example 5 is graph 2x squared plus x plus 1 by determining whether or not the graph opens up or down by finding the vertex, axis of symmetry, y-intercept, x-intercepts if any, and then determine the domain and range, find where it's increasing and decreasing. So for part A, the given function is 2x squared plus x plus 1. Determine whether or not that opens up or down. Well, that's easy to determine because the coefficient on x squared is positive, so we know that this graph does open up. Find its vertex. So again, the vertex is also one of those things that's really easy to find. In this case, we're just going to say that h is equal to the opposite of b over 2a. So our b value is 1 and a is 2. So we get an x-coordinate of negative 1/4, and then we want to find the y-coordinate that corresponds to the negative 1/4. And we do that by just evaluating our function at negative 1/4. And when we simplify this, I'll put k equals so that we know that we're finding the y-coordinate of the vertex. We get 2 times 1/16, which is going to be 1/8, minus 1/4 plus 1. That will simplify to 7/8. And so there's our vertex, negative 1/4 and 7/8. So with the vertex being found, the axis of symmetry is easy to find. I better label this vertex. So the axis of symmetry is going to be x equals negative 1/4. That is your x-coordinate of the vertex. To find the y-intercept, I'll do that in blue. We just replace x with 0. So I'm going to go up here just immediately under the example itself. If x is 0, this term is gone, this term is gone, and we're left with 1. So we have a y-intercept of 0, 1. And then to find the x-intercepts, we will just find where this graph crosses the x-axis. And so if we want to find those x-intercepts, we need to factor this. So we can go through factoring, or we can just simply graph it. And sorry, I keep moving my cursor up and down. Let's use the quadratic formula to determine. Actually, let's look at the discriminant. Remember, the discriminant is b squared minus 4ac. Before we go through a whole lot of work and try to find any zeros if they exist. So in the case of the problem that we're given, b is positive 1, a is positive 2, and c is positive 1. Well, when we simplify this, we get 1 minus 8, which is going to be the square root of negative 7. The discriminant is negative, so that means that this has no real zeros, and we don't have to try to find those now. So if we wanted to graph this, the vertex is at negative 1/4 and 7/8, and we have a y-intercept of 0, 1. So symmetry tells us that there'll be another point equidistant from the vertex. The graph opens up, and you can see why this did not have any real zeros for its solution, because the graph is entirely above the x-axis. The domain, all real numbers, we've already discussed that. That will be the case for every quadratic, but it will change when we start talking about rational expressions. But for now, we're just simply talking about quadratics. The range, because the graph opens up, we look at the y-coordinate of the vertex, which in this case is 7/8. And this graph will go up to positive infinity. Remember, if it opens down, it's negative infinity up to the y-coordinate of the vertex. And the function is increasing on the interval from negative 1/4 to positive infinity. That's our increasing function because all the y values are increasing from that point. And from negative infinity to negative 1/4, our y values are decreasing. They started out high on the far end, but they are decreasing as we move from left to right. And with example number 6 here, we're asked to find a quadratic function given its vertex that has a y-intercept of -3. So that may not be the easiest thing to do, but we can come up with it relatively simple. And I say it may not be the easiest thing to do at first glance, but it is pretty quick and simple to do. What we do know, if we use the vertex form of a function, is that it's x minus h quantity squared plus k. We know from this problem that we're given our value for h and our value for k. So let's substitute in what we do know. It's going to be x minus 1 quantity squared plus -5. We'll just put it as minus 5. What we're missing is this value for a. We know that we have a y-intercept of -3. So a y-intercept only occurs when x is equal to 0. So we can further do some work with this equation by replacing y with -3, and we can replace x with 0, and this will give us something that we can solve for to find the value for a. So that's going to be -3 is equal to -a minus 5. Add 5 to both sides. Whoops. And then divide by -1. So we get an a value of -2. So putting together everything we know that h is 1, k is -5, and we know that a is -2. We can write out our quadratic. It will be the form f of x equals -2 x minus 1 quantity squared minus 5. And there's your quadratic given the vertex and the y-intercept. Max and min. So max and min is also something that's very simple and quick to find. It has a maximum value if the graph opens up, or opens down rather. It has a minimum value if the graph opens up. You simply find the x-coordinate of the vertex, then you find the corresponding y value, and you have found either the max or the min. So we'll do that one also by example with number 7 here. It says to determine whether the quadratic function has a maximum or a minimum value, and then find that maximum or minimum value. So looking at the coefficient on x squared, it's +1. So if it's positive, that means it opens up. So since the graph opens up, it means it has a minimum value. So to find that minimum value, we need to find the x-coordinate of the vertex. Remember, x equals -b over 2a. So the opposite of -4 would be +4. A is 1. So we get an x-coordinate of 2 for the vertex. Then we want to find the corresponding y value, and that will give us the minimum value of this function. So we take the given function and we evaluate it at 2. So that's going to give us 4 minus 8 minus 5, which is going to be equal to -9. So our minimum value is -9, which occurs at the point 2, -9. We can verify that graphically. It's x squared minus 4x minus 5. So I'm going to go to Desmos here. And we have x squared minus 4x minus 5. Want to verify that this is the minimum. It's 2, -9. And we came up with a minimum at 2, -9. So steps for graphing quadratics, if you're doing these by hand, these are your three option, or your two options rather. You can read through those. We've done examples using both, and that will help you with your suggested problems for the assignment. I do encourage you to look at these suggested problems. I know that things are a little bit different now than what they were while we were in class. So please look at these, and if you have questions, ask me. I will still probably be sending out quizzes to you guys to do. Those I will expect you to turn in to me. So don't just ignore the suggested problems. You're still going to have to kind of be responsible for them. If you guys need anything at all, please remember you can reach out to me on Remind. You can email me. I still want to set up a Zoom class for tomorrow or Friday, whatever works best for you guys. If you'll just let me know, and we'll get that taken care of. So I hope everybody's having a wonderful day, and I will be talking to you again soon.